Greetings to everyone. I'm Vaishnav Sudesh, pursuing my third year in BTech Computer Science and Engineering at VIT Chennai. Today, I would like to present to you an extremely useful educational project called as Nand2Tetris. So let's look into it. So Nand2Tetris is a project teaching computer science from the ground up using a systematic and hands-on approach. The project involves building a complete general-purpose computer system from the ground up, starting with the simple logic gate, which is the NAND gate, and gradually building up to a functioning computer system capable of running games and other applications. It was created by Professors Norm Nissan and Shimon Shokin and focuses on building logic gates and complex logic components, for example, adders and registers. This project encompasses everything right from designing and building the hardware to writing a simple operating system and a high-level programming language. This was developed in order to provide a deep understanding of computer science and how computers work to various students as well as enthusiasts. It builds a simple computer architecture, including the CPU and the memory, and it involves writing low-level assembly language and creating the assembler to convert the code. So let's have a deep look into our project. Our first project involves building several logic gates. So what is a logic gate? It is a fundamental concept of digital circuits. It can be termed as the basic building blocks of circuit which perform logical operations on one or more binary inputs, but it only produces a single binary output. And the different logic gates to be built in this project involve various types such as elementary, like NOT, AND, OR, XOR, multiplexer and demultiplexer, which is MUX and DMUX. Then 16-bit variants as well as multi-way variants are also present. These logic gates can be combined in various ways to form more complex circuits that can perform more advanced logical operations. So let us come to why is NAND gate particularly used for all these purposes. Because it's considered as a universal gate due to a lot of advantages such as easier construction, simpler and streamlined design, easier debugging and maintenance, etc. They can also be easily constructed using other electronic components. But most importantly, why it is used is that all other gates or Boolean functions can be implemented using NAND gates. So in the figure I have provided below, it shows the implementation of the OR function using NAND gates only, using two inputs A and B. So let us come to a very important point in this project, which is Hardware Description Language, or HDL in short. It's a programming language used to describe the behavior of digital circuits and systems. It is used to design and simulate digital hardware before it is implemented in an actual physical integrated circuit. HDL allows designers to model and simulate complex circuits quickly and efficiently. All the programs that we do in this project are written in HDL languages for their execution in the software. We come across two common HDLs, namely the VHDL and the Verilog, both having a unique syntax, as mentioned here. Now, before we move on to demonstrating, let us have a small talk about the simulation. So this process is done using the hardware simulator tool from the Nand2Tetris software, which is downloaded from the internet. And in that, we can perform various ways of simulation, such as interactive script-based with or without compare files. So as you can see, in this window, we have 4 boxes here, which uh, include the input pins, output pins, the HDL script, as well as the internal pins. And this is the output screen on the right, where the corresponding output of the program will be displayed. So now let us move on to demonstrating so this is the website which is used for downloading the software, which is nand2tetris.org, and it has several specifications for Mac users as well as Windows users. Now we can share this. So under the downloads folder, I can click Nand2Tetris. The folder is available there, which is being downloaded. And here we can see 2 folders, and which we are interested in looking at tools. And here we see the hardware simulator. This is where we should work on. So this is the window of the software, which I had previously shown, having those boxes. And let us start with running each of them. So we have all the 15 gates in the form of HDL files. Their functions are written there. We'll start with AND. We first load the chip, as I did now, and the respective windows appear in each of these boxes. Now we'll load the script, and you can see it's a TST file. Now for the AND function, I loaded, and this is the HDL language code which has to be run. So we run the code. And we present the output for it. And we can use the compare panel to observe the output for it as well. So as we can see here, the output is 1 only if both the inputs A and B are 1. That is how an AND function actually works. So in this case, it gives the correct output. Now let us work for other functions. So let us take OR. And it's OR here. And let's run it. Can check here, and here the case is different. If any of the inputs are 1, the output comes to be 1. And let's go with NOT, which is one of the simplest gates, where it is just inverting the input. And we first have to run it. And let's compare it. So 0 is inverted to 1 and 1 is inverted to 0. So that's the case for NOT. Now let us check for 16 cases, 16-bit variants. This is for AND 16. So let's see what should be the output for this case and produces such kind of result. Let us try for the other functions with 16-bit. So we can run through this and observe as well as analyze the output. Here we are seeing more of ones here, completely ones. And for not 16, so this is the case. All the values of this bit string is inverted. Similarly, all ones are inverted to zeros and vice versa. And now we can load a multiplexer and demultiplexer, or mux and demux. And we can observe the output for it. So this is the output column, which is based on these three inputs. Now let us go for demux. And this is the respective result for it. Now we have completed the basic functions. Now let's go to 4-way and 8-way of demux, followed by 4-way 16 and 8-way 16 of mux. We'll see what result is there for all these four functions. So let's check them one by one. So as we can see, there are 4 ones in a diagonal, which is for the 4-way demux. And for the 8-way, let's check. And here we can see 8 ones in a diagonal. So that is the difference. Let's move on to mux. So we see this respective output. Now for this, so it's pretty similar to the previous case. And we're done with these 4 now. And we can see the mux 16 as well, which we haven't looked at. So the output just run, and this is a full output for it. And now we'll see the OR 8-way. So in this case, we have 1, 0 and 4 ones as the output. So with this, we have covered all the gates and analyzed their outputs. And with that, I'll come to the end of my presentation. I hope you enjoyed it. And this also brought us an insight for learning more about how the computers function and the entire process behind such amazing calculations and amazing simulations, etc. And thank you for watching.